IGCSE Computer Science, Syllabus Statement 2.1.1a, show understanding that every computer system is made up of subsystems, which in turn are made up of further subsystems. So I just thought that this video is going to be, well, in terms of content, not quite long. So I thought I might talk about paper 2 a bit before we actually look at this. So paper 2 is 40% of your computer science grade. It's just like the theory paper, it's an hour and 45 minutes long, but the reason why it's 40%, the reason why there's not that much on the paper, is because, the reason why the paper is the same length as paper 1, even though there's less stuff, is because it takes longer to actually write programs. So yeah, the first question on the paper is always going to be the pre-release question, and it's going to be the longest. They're going to ask you to do a few tasks, explain like how you do the tasks, like ask you to comment on your efficiency, ask you to they could throw pretty much anything at you, like what test data would you use here, or what data types would you use, declare the variables that you use here, and so on. So yeah, and then the next questions include like tracing flowcharts or pseudocode and filling in trace tables, then finding errors in flowcharts or code, and databases. So that's pretty much the entire course for paper 2 in a nutshell. So it's important that we know some of these concepts because we're going to be using them in A, the pre-release question, and B, in other questions that the test might throw at you. So yeah. So a computer system is a device which performs a task or solves a problem. It's made up of hardware, software, data, communications, and people. Why people? Well, firstly, we make these systems. We make these computer systems, and we use them. So a computer system is made up of subsystems. These subsystems are made up of subsystems, and so on, until the subsystems only perform one task. So what's the point of having a subsystem? What is a subsystem? What's the point of having a subsystem? Or subsystems? Well, subsystems are basically used to break up the whole system into sort of blocks, just to make it more, easier and more efficient. And we're going to be looking at this in the next video, but just as an example, say you had an alarm clock app on your phone. So there might be like 2 or 3 or 4, or like a few functions that it performs, such as like setting the time, checking the set time against the current time, and then sounding the alarm. So you could break that up into those 3 subsystems of the whole alarm system, and then with those 3 subsystems you can break it up into even more subsystems. So like for the alarm, you would have the set time and set alarm on, or turn it off. For the check time, you could have, I don't know, you can think of something. And yeah, that's pretty much how it works. So the advantages include, firstly, if you're writing code for this, your program looks neater. It's broken up into folders pretty much, so it makes everything look more organized. You put all your program files into folders or categories, makes it easier to navigate, makes it easier to therefore debug, and so on. And also, if you're working on a project with other people, then other people can focus on certain subsystems to make use of specialization and therefore efficiency. So yeah, that's pretty much it. So because I think that this isn't enough stuff to cover in this video, I decided to do this. So Here is something called a structure diagram for the computer science course. So this is sort of the system, the computer science course. We break it up into two parts. We break it up into theory, problem solving, and programming. We break the theory up into other topics. So we looked at data representation, communication and internet technologies, hardware and software, security, ethics, and we can break these up too. You break data representation up to binary, hexadecimal, and data storage, data transmission, and so on. And hardware and software had a lot of stuff. And we couldn't really break down security, but if you want to, you could. And you can even break these down too into syllabus statements. So that's pretty much how it works. And as for problem solving and programming, well, we'll see that. I thought this was a good idea because this also gave you a chance to see what we're going to be covering in the next videos for for paper 2. So here. So this is the topic we're looking at now. Then we're going to look at programming and then databases, and we can break these up too into problem solving and design, pseudocode and flowcharts, and programming concepts, and arrays. Databases we can't really break up because it's really short. In fact, databases is kind of like the ethics of paper 2. It's really short, but the thing is, you know that they're going to ask you a databases question on the on paper 2 because the content of paper 2 is really it's not that much. It's pretty short. So you kind of know that they're going to throw in a databases question. So that's pretty much it. Thanks for watching, I guess, and the next video will explain this whole thing a bit clearer. We'll look at some examples as well.